Hello, welcome to 1.6 Linear Inequalities in one variable. So we're going to continue our review before we jump into the new stuff. Linear inequality is an equation in which the equal signs are replaced by less than or equal to, greater than or equal to, or greater than. Some texts also include the not equal to inequality, but this book does not. A solution to a linear inequality will typically be a range of values, not a specific value, as is the case for equations. The process for obtaining a solution for inequalities is similar to that for equations. If you have a less than b is equivalent to a plus c is less than b plus c. If c is greater than 0, a divided by b, a is less than b is equivalent to ac less than bc. If c is negative, a less than b is equivalent to ac greater than bc. That is, if you multiply or divide by a negative, the sign changes. Now, the third case, multiply and divide by a negative will reverse the sign. So example 1 says, solve the following linear inequalities. Describe the solution set using interval notation and by graphing. Okay, so let's distribute here. 8.5y minus 3.5 is greater than or equal to 7.5 minus 2.5y. So I'm going to add 2.5y to both sides and add 3.5 to both sides. So it gets the variables on the left, constants on the right. That's how I like to do my inequalities. So this is 11y is greater than or equal to 11. Divide by 11. Y is greater than or equal to 1. So that's going to go from 1 to infinity. Or here's your 1 from here on. Now, a compound inequality is a statement containing two inequality symbols that can be interpreted as two distinct inequalities joined by the word and. It appears a less than b less than c, where you want to isolate the variable in the middle part of the inequality. The alternate form of the above is a is less than b and b is less than c. So I'm going to go to the next page. Feel free to pause. So solve the following compound inequalities, or it's only one. Describe the solution set using interval notation and by graphing. So we'll have negative 10 is less than negative 8 minus 2y less than or equal to 9. I'll add 8 to all three parts, and I'll have negative 2 is less than negative 2y less than or equal to 17. Divided by negative 2, check it out, it's negative 2, so it's going to switch the signs. 1 is greater than y, greater than or equal to negative 8.5. So negative 8.5 is less than y, less than 1. Equal there. Negative 8.5, comma 1. If I graph this, we'll have the brackets because it's equal to the 8.5. That's why it's a bracket there. And we shade in between. Now, solving absolute value inequalities. An inequality in which some variable expressions appear inside absolute values, symbols. Absolute value. You do the following to solve them. If you have the absolute value of x is less than a, you make it the compound like this. Negative a is less than x less than a. And if its absolute value of x is greater than a, you do x less than negative a or x greater than a. It's different than this up here. So here it's x is greater than the negative. Here it's x is bigger than the positive. Going on to example 3 for these couple. Solve the following and describe using interval notation and by graphing. So I'm going to subtract the 4 first of all. The absolute value of 3 minus 2y is less than or equal to 2. So negative 2 is less than or equal to 3 minus 2y less than or equal to 2. I will subtract 3 from all the parts. So negative 5 is less than or equal to negative 2y less than or equal to negative 1. And divided by negative 2, I'm dividing by negatives, so it's going to switch those signs. So 2.5 is greater than or equal to y greater than or equal to 0.5. If I were to graph that, from 0.5 to 2.5. And the next one, first I'll divide both sides by -3. That's going to be the absolute value of 4 minus t is greater than 2. We divided by a negative, so the sign switched. So it's 4 minus t is greater than 2, or 4 minus t is less than -2. If I subtract the 4 from both sides, negative t is greater than -2. Divided by -1, t is less than 2. Or, if I subtract the 4 from both sides, negative t is less than -6. Divided by -1, t is greater than 6. So this, if we were to graph this, we're going to have t is greater than 6, so parenthesis going up that way, or less than 2. And this is going to be -infinity to 2 union 6 to infinity. Okay. So feel free to pause. I'm going to go on to the last page. We have one problem left here in this section. Example 4, in a class in which the final course grade depends entirely on the average of 4 equally weighted 100-point tests. Cindy has scored 96, 94, 98 on the first 3. The professor announced that there will be a 15-point bonus problem on the fourth test. Anyone finishing this semester with an average of more than 100 will receive an A+. By the way, we don't have A pluses here. What range of scores with the fourth test give Cindy an A, and what will give her the A+? So we have 90 is less than or equal to 96 plus 94 plus 97 plus the x, all divided by 4, less than or equal to 100. So 90 is going to be less than or equal to, if you add this up, it's 287 plus x over 4, less than or equal to 100. Multiply through by 4. And 360 is less than or equal to 287 less than plus x less than or equal to 400. So we subtract 287, and what do we have here? 360 minus 87 would give us her 73 less than or equal to x less than or equal to 113. So Cindy needs between a 73% and a 113% for an A. Cindy needs a 114% to 115% for an A+. Well, that's going to do it for section 1.6, so send me your questions. Thanks.